So the first problem is you have to find the rectangular equation relating y and x, so not convert, but find the rectangular equation, and you have to list the restrictions. You guys all, like, this is, so it says x is equal to -2 sine squared t, y is equal to 3 cosine squared t, okay? What's the formula that we use? Yep. Wait. So can you guys read this or?
Rewrite the sine squared is weird. No.
Squared.
No, the two. It makes it look like a 4.
There you go.
It's terrible. Like a 4.
How is this a 4?
Move the T over.
You know, if you did it on a whiteboard, it'd be better. Can you get one of those?
Nah.
That looks like an -2.
No, it looks good. It looks fine.
Oh.
Your handwriting is perfect. Jenny thinks you're perfect.
So we use the formula. Okay. Then what do I do next? Instead of me saying it, you guys can come.
We're bailing you out.
You plug it in, so we need to solve for sine squared t. Sometimes you will have plus or minus 1 here, so then it won't be as easy as solving for this problem. So -x/2 quantity. Now that's it. Plus, for cosine squared, what is it? y/3 equal to 1. Good?
What's the step before that? Can you explain how you got y/3?
I solved for cosine squared t and sine squared t. Now I could have solved for, if this wasn't squared, I would have solved for sine of t and then squared this portion. Yep. So
we'll always say find the rectangular equation.
yeah, I mean, they could ask you to convert it into Cartesian coordinates or rectangular coordinates. What? For this problem, they ask you to find the equation that connects both of them. Okay. So that's our equation. And then we have to find the restrictions. The restrictions on sine squared t are always from 0 to 1, I believe. So then we have to find the restrictions on x. Well, we know what sine squared t is. It's this -x/2. So then you just solve for that. So let me rewrite this as 0 less than or equal to -x/2 less than or equal to 1. I multiply 2 to both sides divided by a -1. So I end up with 2, or -2 is less than or equal to x less than or equal to 0. If you solve for x, you multiply by 2 to both sides, and then you divide by a -1, which flips the signs. So that ends up being the restriction on x. The restriction on cosine leading to the restriction on y is 0 is less than or equal to y/3 less than or equal to 1. Therefore, I'm going to write it here. We got 0 less than or equal to y less than or equal to 3. Cosine squared t. Therefore, yeah. Any questions on this part? Yeah?
What's rectangular? What is about a rectangular equation? I don't know what that meant.
It's the equation using rectangular coordinates connecting x and y.
That's
Those are rectangular.
ax squared.
Well,
Do you care?
Yeah, well, they just keep calling it Cartesian and parametric.
Rectangular coordinates are when you use x and y. And then Cartesian/parametric, I believe, is the same thing, where you have radius and theta, and then you'll have the z.
Cartesian is
It's Cartesian x and y?
Yeah, that's like the main word.
Okay.
Yeah.
So those are Cartesian and rectangular are equivalent then. Let me look at it once more. Yeah, sorry about that. So your parametric equations are with cosine and sine and stuff, because you have theta in it. Your Cartesian are your x and y coordinate system, and then eventually you get cylindrical, which is, we won't go into that. So did that answer though? This is your rectangular equation because it has x and y in it.
Would it have been wrong to solve for y? Instead of y equals.
You should just keep it like that. Yeah. Because then later on you have to find the tangent line where you solve for y in some manner. So now we have to graph this function with t equal to 0, okay? And t equal to pi over 2. Essentially, it comes out to just be the restriction. But if we plug in a 0 for x equals negative sine squared t, what do we get? Into x is equal to negative 2 sine squared
You
t.
get 0.
So we have the coordinate 0, comma, plugging in 0 into cosine squared t. Yeah. That's at t equal to 0. You do the same thing with t equal to pi over 2. Plugging in those values, we get another coordinate point, negative 2, comma 0. T equal to pi over 2. So then our graph is going from time 0 to time pi over 2 with this line. And essentially, the problems that I've seen, it comes out to be the limits. The max limit, and then you have another coordinate. But then you shouldn't just go off by that, because you don't know what, like, t equal to 0 is 0, comma 3, but you might confuse it and make that your end limit. Yeah.
So the arrows are just going in the direction that t is increasing.
Yeah. So the easiest way to do it is to actually just plugging in 0 for x and y, plugging in pi over 2, and then drawing the line and putting the arrow on. Okay. 8 points maybe? I can't, like, it's covered a little, but they gave you t equal to 0 and pi over 2.
Oh, okay.
Yeah, that was given. Are you guys good with this problem? It should be one of the easiest ones on the exam.
I'll raise it. I'll use for it.
No, we have to.
Yeah.
Why? How do you know what the direction is?
Because when you plug in t equal to 0 for x and y, are you just asking that for random purposes?
No.
Okay. When you plug in t equal to 0 for x and y, you get 0, comma 3. They tell you the second point is when t equal to pi over 2. You plug those in, you get negative 2, comma 0. So your time equal to 0, going to time equal to pi over 2 is this direction, connecting the 2 points. Did that make sense? Yes or no? If it didn't, I can go like actually write it out. You won't get any hyperbola on this sort of problem, but you can do that with the last unit. Like this sort of problem putting into a rectangular equation. Now you like this is only 2 coordinates to have a hyperbola. Don't you need? Do you need 3? No, to have a. Never mind. This actually is a hyperbola, is it not? There's a minus sign. There's a minus sign. Oh, it's not squared. Never mind. Oh.
There's a minus sign.
So just look at your problem, and then the hardest it will get is okay. So all the problems that I've seen like this with graphing, is a straight line going from t0 to some time. Those are the problems I have seen. In my experience, this is as tough as it's going to get with this sort of problem.
The one with the hyperbola on our homework was with caution.
But did the graph and everything turn out to be like that?
It was like,
Oh, no?
it was on hyperbola, but you couldn't use this side of the main. But I'm just telling you, like, that's what you would have hyperbola. It's just in like the parabolic truth, right?
And then you have to convert rectangular equation and stuff
Yeah.
with that?
Not right.
You have to use it. You have to use the same method. You have to use the cosh minus sin equals 1. You do the exact same stuff.
Okay. We can do that at the end. But on my exam, I think it was as simple as this up here. You never know what they do put on it. Let me look at something. These tests, these are actually were once given to students. What? What do you mean aren't anymore? Oh, so they're never gonna do these exact problems again. So that's why they've given them to me to show you guys. So they have like hundreds of different problems. So are we good with this problem now? Sorry about that confusion. So what was the formula? Cos squared? Was the equation, is the equation cos squared t minus sin squared t equals 1?
Basically, what happens, instead of saying x equals negative sin squared, you just be sinning. And so then you would have to square it.
Okay. The process should still be all the same though.
Yeah.
Like you may get 2 coordinate points, if that's possible. But yeah. Okay, I'm gonna erase this. Okay guys, calm down. We have x is equal to t plus sine t, y equal to t plus cosine of t. Alright guys. Shh. So part A, we have to find dx dt. And what would that be?
1 plus cosine.
Yep. What is y prime?
You need more steps. You want dy dt? That we have.
What does y prime mean? See, there's a difference. That's what I'm asking. What is y prime equal to? Dy dx, okay?
Yeah.
And then we can say that that is equal to dy divided by dt. Everything. I think, okay, the person's saying, okay. Dx divided by dt. What? You can borrow it.
Yeah, you can just give us the old pads. New one.
Okay.
I'm sorry, we'll be good.
Does this make sense? Dx dt is with respect to time, but when we say y prime, we mean it as respect to dx. Okay? So then this simplifies down to dx dt. I mean dx dy dx. Yeah. So then we just sub everything in. What is dy dt? Well, you can do it.
1 minus
Divided by 1 plus cosine of t.
this looks like
Did that make sense?
conjugate.
Hold on. No, we can leave it there. Do you guys know what this is? This notation?
Yeah.
Okay.
I don't
When you have a dot above it, that means it's with respect to time.
know. Okay.
When you have prime, dx. And what is x prime if it's just x? That's equal to 1. In this case. But side note. Okay. You have to know if it's respect to t or y or x or something like that. So then we need the derivative of y prime that's taking the derivative of this, right? With respect to t. So then what rule do we use? The quotient rule. So we have 1 plus cosine of t times the derivative of the top, 0 minus cosine, sorry, the derivative of the bottom. Did I do it? Low d high minus high d low divided by low squared. So this problem actually in its entirety is worth, let me count it, 8 points. You guys should get all of them. Yep. I mean, this is pretty simple stuff. This is just using derivative. What?
What class are you in?
I only had up to physics 2, but this semester I'm doing biotransport, which is fluid mechanics and heat stuff. But some of you guys will take thermo too for mechanical engineers. So you just simplify it now. We are left with negative cosine of t minus cosine squared t plus sine of t minus sine squared t divided by 1 plus cosine of t quantity squared. That's equal to sine of t minus cosine of t minus 1 divided by 1 plus cosine of t quantity squared, because these two terms can combine to equal a negative 1. Good?
So for part B, it asks for y prime and that's
Oh, sorry, this is part C. Because, yeah, part B was just y prime. Part C is the second derivative, which is also d squared y over dx squared. That's equal to this. Yeah, remember that. You guys have this copy? Because part E, it's finding the tangent equation the tangent line y equals to f of x at t equals to pi over. Yeah.
We didn't do d squared y over dx squared, because you're supposed to also divide by dx over dt.
This, if you simplify this, you get that.
No,
Let me figure out how.
no. You have the top part, d squared y over dx squared is, so maybe it's y prime over dx dt. So you just found over dx dt. And that's just a formula we memorized.
That's less than simple.
For what?
Yeah, so it's the root of y prime over x side. That makes it simpler.
Yeah. Yeah.
Wait, what are you guys trying to say?
You
You
forgot your
didn't
x
find
out.
d squared y over dx. So you gotta have it.
Oh, never mind, I didn't.
Oh.
There you go. You guys got it? That's why I need to prepare more, but okay. don't care. Did this make sense?
Wait, no.
What?
So, do you have a bug?
This is derivative of y prime with respect to t. Did that make sense?
Yes.
Yeah.
I skipped part D actually,
EPG. And I teach us.
which is d squared y over dx squared. And this now is equal to dy prime respect to dt divided by dx dt. There you go. Good?
Yeah.
That's equal to sine of t minus cosine of t minus 1 divided by dx dt is 1 plus cosine of t times the denominator here. We get 1 plus cosine of t quantity q. You guys happy? Yes. I'm just kidding. That was good though. You guys found my mistake. This is, they'll tell you to solve for this, right?
Yeah.
So once you have y prime, you just take the derivative with respect to t. They'll tell you to solve for this, but you do need to know this part. Are you guys good with this problem now? And then we still have part E. Good? We are good. We sort of need to hurry up now. The last part is finding a tangent line at t equal to pi over 2. Why did they use 3 over 2 pi?
Where are they trying to think on at?
They say t equal to pi over 2, but then they do it with a different. Oh, they wrote it wrong.
Negative side?
They wrote it wrong. Wait, sorry. Here you go. T equal to 3 pi over 2. So x1 is equal to t plus sine of t. All right, guys, calm down. So let's quickly move through this problem. This is like finding an equation for a line. You need coordinate points. At t equal to 3 pi over 2, x is now equal to 3 pi over 2 minus 1. For y, t plus cosine of t. We have y is just equal to 3 pi over 2, because then that goes to 0. So now we have two equations, or two, rather, coordinate points. dy over dx, which is the slope, is equal to 1 minus sine of 3 pi over 2 divided by 1 plus cosine of 3 pi over 2. Is that right? Yeah, that's what we found. This is equal to 1 minus a negative 1 divided by 1 plus 0. So our slope is equal to 2. This, yeah, they'll give you the t. Yeah, because that's at the point we're trying to find the tangent line to the graph. So then the equation that I always use is y minus y1 equal to m times x minus x1. So y minus 3 pi over 2 is equal to 2 times x minus this number, which would be 3 pi over 2 plus 1. Therefore, you end up with a y is equal to 2x minus 3 pi plus 2 plus 3 pi over 2. When you multiply this out and then bring the 3 pi over 2 to the other side. And then you simplify that to get y is equal to 2x plus 2 minus 3 pi over 2. So you can leave it this as your answer. Or you can simplify it by multiplying the 2 by a 2, so it's 4 minus 2. All over 2. So if I had gone through this problem correctly, this problem is not hard. Okay? It's just taking the derivative with respect to time, knowing to take it with respect to x, and you definitely need to know this formula, which is, not something hard because it's the same thing. Any questions? You guys ready to move on? This problem, on the other hand, can get weird. Well, the math is not hard. You just have to accept Jim something. Jim, wait. Moiberg? How do you say his name? That dude. His theorem is cis theta to the n is equal to cis n theta. We have to find cosine of 4 theta.
Can you write it as cosine I sine theta? It's confusing when they just write this.
Okay, let me write down the problem first. We have to find cosine of 4 theta in terms of sine of theta and cosine of theta and sine of 4 theta with sine of theta and cosine of theta. Okay? Calm down. Okay. So that's what they give you. So what you do need to know, though, that this is equal to cosine of theta plus I sine of theta to the 4th power, because our n is equal to a 4. Okay? And then this is equal to cosine of 4 theta plus I sine of 4 theta.
So yes, this means cosine theta plus I sine theta.
Yeah.
And sine cosine theta twice.
What did I do? What?
Cosine 4 theta.
Well, that's how they phrase the question. So we have to find cosine of 4 theta in terms of sine and cosine, and sine of 4 theta in terms of sine and cosine. So 2 things. So your n value is the 4. So you have cosine of I sine theta to the 4th power, and then cosine of 4 theta plus I sine of 4 theta, which is the n is equal to 4 again, so you have 4 theta. Do you guys understand how to write this out, though? Because that's really the hardest part. Yeah. They give you this. Knowing that it's 4 theta, you know your n is equal to a 4. So then you plug in a 4 here, and then that is equal to this phrase to the 4th power. You plug in a 4 here, so then it's equal to that. So now the part is oscillating our complex number with the real and imaginary part. So is anyone having trouble knowing why this is equal to this? This line is equal to the top.
Can you show like the original groups, definitions? Like where it's like E raised to the R E raised to the I theta.
You want me to write that? Because it's not necessary for this problem. But, no. In other ones I will, but this will be given to you. Yeah. But this is what you have to know. So if they ask cosine of 5 theta and sine of 5 theta, you know your n value is a 5. So it's cosine of theta plus I sine theta, quantity to the fifth power equal to cosine of 5 theta plus I sine of 5 theta. Did that all make sense? Because then the problem is really simple. Well, it's not simple, but it's doable. Then you expand this out, because it's to the fourth power. You can use the triangle. Pascal's triangle. So that states that the first term will be to the fourth power, so cosine of 4 theta. Then we'll have plus cosine of 3 theta, or cosine cubed theta, times I sine of theta, plus 6 times cosine squared theta, times I sine of theta squared, plus 6, sorry, plus 4, hold on, cosine of theta, times I sine of theta cubed, plus I sine of theta to the fourth. Okay. Now, what was your question? Here? Isn't it Pascal's triangle plus? So the first term you have a 1, then you have a 4, then you have a 6, then you have a 4, and a 1 again. So the power is to the fourth on cosine cubed, cosine squared, no power, and then you don't have it, and then you do the same thing backwards to the second term. Okay? So that's with cubed. That's with to the fourth power. And then there's third and second, you can just multiply. So then so this is all equal to the first part. So then you need to organize everything. This here, not this, right here. What's I squared? So this becomes negative sine squared theta. This quantity here is I sine of theta cubed. What's I cubed? Negative I. So this is negative I sine cubed theta. And then this last part, what's I to the fourth? 1, so it's sine 4 theta, or sine of theta. Okay. Hold on. They wrote it wrong? Yeah, sine to the fourth power. So we'll just So that's the thing about this problem, is you have to be very careful with the algebra. Or whatever, the multiplication. So then grouping them, we have cosine 4 theta minus 6 sine squared theta cosine squared theta plus sine to the fourth power theta plus I times 4 sine of theta cosine cubed theta minus 4 sine cubed theta cosine of theta. Okay, and that's equal to the what we had in the beginning, cosine of 4 theta plus I sine of 4 theta. Okay, yeah.
Will we have to write it out like that, or can we just go and jump to the real imaginary parts?
I would write this out.
Write it out.
I would write it out because it's otherwise you would easily make a sign mistake or something.
Okay.
So just write this out. But you guys should already know that the real part is the first part, and cosine of 4 theta is then equal to all of this. Yes? And then the imaginary part is sine of 4 theta, which is this part.
How many points is it? That's all it is.
It's hard to see. 5 points.
How much?
That's all it is.
5 points. See,
I don't know what it is.
I think
Yeah,
these are actually pretty easy 5 points compared to the rest of the exam. But because once you realize this, it's just multiplying it out. Okay? Then it's putting them in groups. So is there anything, do you guys have any questions about this or anything you find hard about it? Yeah. For the second part? No, you're relating the part. So this is the imaginary part. So that's just equal to sine of 4 theta. Yeah. Yeah.
Will you write down like the first couple lines just that time?
Yeah.
So 4 times is cosine minus sine.
So you probably this, but that's probably as much as you'll need to know. But do you know how to find each consecutive line though? Yeah. You
What's the fifth one?
you want me to write the fifth one?
Yeah, 'cause that's the one.
1 5 10
Thank you.
Yes.
What's the next?
I swear to God.
I think he'll just go to the fourth one, personally. And then I think I told you guys. How did I told you guys the cube? Like so, right?
Same opposite of.
So the first one was just x plus y, right? Was this it?
Oh,
I don't know.
yes. Or that's plus, yes.
That's what I use. But no, it's better to do Pascal sign. Because you still have to multiply them that part. Okay. Are you guys good with this problem? Okay. Okay. This is where it might, or no, it's, we'll do it. It's not that bad. I was going to say that's hard. They tell us z is equal to w to the fourth negative 8 minus 8 to the square root of 3 I. So it's a complex number. They tell us z is equal to r cis theta, comma w is equal to rho cis alpha. And then we have negative pi less than theta less than or equal to pi. So we first have to find r value. So r is equal to what? Do you guys remember the formula? Magnitude of z. That's equal to taking the negative out. So we do the actual value of negative 8 times the square root of 1 squared minus, or plus, sorry, the square root of 3 quantity squared. That's equal to 16. Because you get 4 here. Part B, rho is equal to r to the 1 over n. So that's 6t to 1 over 4. This is our n value. So that's equal to 2. Part C. You guys following along? Yeah. Cosine of theta is x over r. Our x value now comes from. How did I do? I know. It's,
The x value is just from the non-I coded, like x minus I one.
no, that's not. Is that what they? Okay. We'll go with negative 8 over 16. So negative 1/2.
Is it always x over r?
It's because if you were to graph it, it's like this is your radius or okay. So the coordinate system is just x on the x-axis, I in the y-axis is place. So and then your hypotenuse would be r. So that's it. So sine of theta.
Can you go over my part?
That's the absolute value of z. I'm sorry, not the absolute value, the magnitude. So you can do square root of negative 8 squared minus or plus the quantity.
Why would it be? Why would it be?
You can square root that. So then you can solve it.
What is W equal? Rho is.
So you can solve it and you get 16.
And what is W equal to? Is that rho sine or?
Rho cis alpha. Cis alpha.
Oh, cis. Okay.
You expand it. So sine of theta would be the I component, negative 8 over square root of 3 over 2. So we get negative square root of 3 over 2. Minus a square root. One thing you do have to now, or you guys come now, you have to realize that since both of these are negative, what coordinate will we be in? Third. Are you guys good with that part? Now we have to find theta. Where does cosine equal negative 1/2 or sine equal negative square root of 3 over 2?
Over 3. I think. Is that right?
Negative 2 pi over 3.
Same thing.
That's knowing your unit circle, where cosine equals to 1/2 and sine equals negative. Should be. We have to find alpha. Do you guys remember the formula for alpha? I believe it's
2 pi k over n.
good. So that's equal to.
This is 1.5.
Yeah.
I thought,
I don't believe you're given that. And you're not. Yeah. So you have negative 2 pi over 3 plus 2 pi k divided by 4. You simplify that, you get negative pi over 6 plus pi k over 2 for for k equal to 0, 1 dot dot dot.
Yes.
Now let me go. Okay. Are you guys good with this part? Because I will need to explain some stuff now. Yeah? So when we say CIS of say alpha, okay, that's equal to cosine of alpha plus I sine alpha, right? Now this is say to a power n. This is to a power n. So then this entire thing we can rewrite it as e I times alpha to the nth power. So e to the I times alpha is equal to the inside, which is equal to, in this case, just alpha.
Is there a reason you use alpha instead of beta?
No. What? I just use alpha because the problem has alpha. What?
Are they testing for the roots?
The WK values, but I'm explaining that this is equal to EI alpha.
This isn't a question.
No, we are leading to the question.
So it's E I alpha to something memorize?
Yeah.
Again?
Yeah.
Yay, not understanding anything.
Because it's like there's some math behind it, but this is
Tyler
the,
Ralston don't care about that.
since this alpha, you just need to know it's equal to EI alpha to the nth power. But then this portion here is also equal to this inside. Okay? So when we have to find W naught, they tell us that's equal to rho cis alpha. Okay? But then we can say that that's equal to rho times E times I alpha. Yes? So then we can, instead of having so many cosines and sines, we can make the problem not have to write everything out by keeping everything in terms of e to the I alpha power. Did that last sentence make sense? Okay. So instead of having to write cosine of alpha plus I times sine of alpha every time, this notation is equivalent. Rho times e to the power I alpha. So then we can keep everything in those terms. And what? Because we're doing not right now.
That's great.
Yeah. Okay. So then when we're trying to find W naught, that's when k is equal to 0. Yeah. So then our equation becomes rho we found was equal to 2. Then we write E, we write I, our alpha, when k is equal to a 0, is just negative pi over 6. So then our W naught is equal to negative pi over 6 times I as an exponent. Yeah. We can stop right there.
They always have us plug in your cosine and sine to get a number.
Oh, yeah, it doesn't have audio.
On the exam, that's how you need to do it. And there's a dyno problem with this way. I don't know why in class today. Okay. On the video, maybe they do it. So this part makes sense. Instead of having to simplify it with cosine and sine, we just filled in what alpha and rho were, and we leave it like this. Okay. So let's do W1. Okay. So you guys try this. So our rho is 2. We have E times I. When k is equal to 1, we have negative pi over 6 plus pi over 2. Okay? And we can simplify the top and have it equal to 2 e I. And then if you do negative pi over 6 plus pi over 2, you get pi over 3. Okay? Now say you wanted to turn this back into this, you have all the notations. This would be your alpha value. Okay? So for W to the second, well, k equal to 2, you have 2 e times I with pi over 3 plus pi over 2. Well, sorry, let's do it here. When it equals to a 2, we have negative pi over 6 plus just a pi. So that's equal to 5 pi over 6. Okay? And then when k equals to a 3, we have 2 e to the I. Adding a 3 in here would make this 3 pi over 2 minus pi over 6, and you get 4 pi over 3. Did this part make sense? Okay. Let's move on to, yeah. Now we have to graph this. Okay. So can I erase all this?
Memorize the versus data.
Now what I wrote on top is given, like the very first one. But now it's like, and then graphing is hard. Okay. They give you guys that with a circle on it. We found 4 values. Okay. The angle that we found, so this is where I actually am a bit iffy on. When k equal to 0, we found negative pi over the angle. We found was negative pi over 6. Or alpha. So our alpha value changes by the ratio of, or whatever, pi over 2, by 90 degrees in this case. Okay? It could be different. So in this case, we have pi over 2. So then our next point will be at 90 degrees to this. And that will be W1. And then we found that our x value was, no, that's not it.
There's a coordinate on it.
Yeah.
The way you find that is by you mean row
Yeah.
cosine into alpha plus I sine alpha, and actually plugging in negative pi over 6 and getting x.
How did you find the x value again?
You have to plug in, so you know how you wrote e to whatever, you have to actually use your row and use your alpha, use row times cosine
Oh,
alpha plus
yeah,
I
yeah.
sine alpha, and take a really long process to get to 4 times. No, right z, right z. Z,
I think this was it. X is equal to r cosine theta.
I don't know if that's word probably. I think row would be row at this point, not R anymore,
Yeah, yeah.
right? And alpha, you should use row and alpha.
Yeah.
That's good.
We have our angles just saying those are the alpha values that we found. So then our angle in this case would be for W2 or W1 it was pi over 3. And then if we were to go 90 degrees again, we'd have 5 pi over 6. W3, we had our angle 4 pi over 5, or over 3, sorry. And give me a sec for the x values. Oh, it's, you write out W with, yeah, for each one, which does take long. But we should be able to do it in the amount of time we're given.
I don't know, maybe I'd like to.
So writing that out, we have rho, that, so it'd be 2 times cosine of alpha plus I times sine of alpha. Cosine, but you should be, should that be a 1 right there?
What? Where?
No, sorry. We should be plugging in alpha values. Say for the first one, we found negative pi over 6.
Out 0, W1, alpha.
Yeah.
You have to find each alpha. You should make 2 columns.
We had alpha,
Make 2 columns.
not though. We add negative pi over 6 to there, multiplied by 2.
Make 2 columns and really want to start it.
So how do you know which one's your x and which one's your y?
Your y value is going to be the alpha angles.
No.
Not always.
Your x is just the real part, and then your
I know.
y is going to be your imaginary part.
Yeah, but the thing is, to answer that for the problem, it's all of the x values are 2s.
I don't know why.
It goes by 90 degrees, so this is pi over 2. Pi over 2 pi. But yeah, that's what I was confused about, because does it work out if we do all that?
Well, that's how they taught it. They haven't done
Yeah.
it. It's always been, you have to write out all the alphas and plug each alpha into that expression to get your x.
Yeah, because this is your real and that's your imaginary.
Yeah.
But that is the answer on the board.
Those all one question.
Yeah,
How many questions?
10 points.
So you look like.
Oh, let me say this. This graph is worth 2 points.
Okay.
Yeah, finding all the W's is worth 4 points, but you guys should know how to do that with once you have alpha, okay? So the graph is worth only 2 points. We're gonna move on. You guys have physics class after this? We still have 2 problems to go. But, okay, let's do this quickly. X is equal to initial velocity cosine alpha times t. You are given that. Y is equal to negative 16 t squared plus v naught sine of alpha times t plus y initial. Yeah. A baseball is thrown from the stands 32 feet above. So this is a projectile problem. So it's thrown 32 feet above. The ground is y equal to 0. It's thrown with an upward relative to the horizontal at an angle of 30 degrees. So it'd be something like that. And this would be 32, and the ground would be here. Find x, the horizontal displacement. So we have to find that where the ball strikes the ground, v naught is told to be 32 feet per second. That's the initial velocity it's thrown at. And then we have to find the time of flight as well. Yeah, it's thrown 32 feet above ground with a velocity of v naught with 30 degrees angle. The ground is at y equal to 0, and we have to find the x and time. So, having that information, we know that y is equal to negative 16 t squared plus 32 initial velocity.
They gave us 32 for 2 different things, 32 feet up.
Yeah.
50 feet up. I think.
Hold on.
And they hold on for 32 feet above ground.
Yeah, it is.
Why?
They tell us that. It's just thrown through.
Okay, what the problem is right there?
It's like a baseball stadium.
Like, is it starting from 32 feet?
We have to know. It's the equation times v naught times t plus height. What is this equation called?
Maybe
Yeah.
the baseball player is like 32 feet high or something?
No, he's on a stadium that's or something that's 30. He's throwing the ball from a height of 32. Why doesn't that make sense? Why would that matter? Technically, that shouldn't matter though, whether he's tall or not. But the formula, where is that projectile formula? Okay. This is the actual formula that, yeah, they don't. Y is equal to negative 1/2 g t squared plus v naught sine alpha times t plus y naught. Okay. So then when we fill everything in, we have negative 16 t squared plus 32 times sine of 30 sine of 30 times t plus 32. This equation you should memorize though.
They didn't give that to us? You said they would give it to us.
You said that you did all the equations.
If they gave you that at the beginning,
But so I found it in Dyna, that's why I was confused. I thought they would give them.
no, what did
Oh, they do give it to you.
Okay.
It's just in the work. It's weird.
Have you not wanted to use 9.8 and use 32?
This is in feet, so you use 32. 9.81 is meters. So then you simplify this equation. Sine of 30 is equal to 1/2. So y is equal to negative 16t squared plus 16t plus 32. Okay? So then that's equal to negative 16 times t squared minus t minus 2. It hits the ground at y equal to 0. So then this equation, the height is equal to 0. So it's 16 times t squared minus t minus 2 equal to 0. Okay? Therefore, we can find time by negative 16 times t minus 2 times t plus 1 by doing factoring equal to 0. Okay? Therefore, t is equal to 2 and t is equal to a negative 1. The negative one doesn't make sense. So finding the horizontal distance is equal to v naught cosine alpha times t. That's equal to 32 times cosine of 30 times 2. Cosine of 30 is square root of 3 over 2. So our answer is 32 square root of 3 t. Did that problem make sense? Way more than the others? Okay. And then we have one more.
What was the final answer?
32 square root of 3 t. Moving on. Find the arc length. Guys, let's quickly finish this. Arc length x is equal to t cubed, comma y is equal to 3/2 t squared between 0, t, and that. And then they say hint. The square root of t squared is equal to the actual value of t, which is equal to t greater than or equal to 0. So they tell you that it's greater than or equal to 0. They tell you all of that. Formula for arc length ds is equal to the square root of dx over dt quantity squared plus dy dt quantity squared dt on the outside equal to the square root of derivative of that is 3t squared quantity squared plus 3t quantity squared times dt. That's equal to 3 taken outside times t to the 4th plus t squared dt. And then we can still take out a t squared from this. So it's 3 square root of t squared times square root of t squared plus 1 dt. That will give us an actual value, but since they tell us it's greater than 0, so that's equal to 3t times t squared plus 1 to the 1/2 power. Cool? Yeah? So then s going from 0 to the square root of 3 is equal to the integral from 0 to the square root of 3 of 3t times t squared plus 1 to the 1/2 power dt. Because it's the integral of ds. So that's equal to 3/2 times, you have to distribute it, But this is u is equal to t squared plus 1. du is equal to 2t dt, correct? So then we have to multiply by a 2 on the inside, 1/2 on the outside, so we have 3/2 on the outside, times u to the 3/2 over 3/2, so it's t squared plus 1 to the 3/2 divided by 3/2. So let's go away from 0 to the square root of 3. So that's equal to, plugging in a square root of 3, we get 3 plus 1 to the 3/2 minus 1 to 3/2. Does that make sense? That's equal to 8 minus 1, because it's 4 to the 3/2 power, which is equal to a 7 length.
Okay.
It's why it's doing an integral, and I did it really quickly, but that should be it.
You give slightly more full answers.
I remember.
With what?
They give more, like, post the exam online, you give as much detail as you can.
I am not allowed to post the solutions. In the videos I can, but I'm not physically allowed to post the solution. Everything that is written on this, it was written on the board.
You can only post that.
Yeah. And I like the solutions, the process I'm not allowed to post, but everything that is actually on this, I write on the board, which is on the video. But yes, number 10 is hard, but the graph is worth only 2 points. The way to do it is really long, and that's why I was confused why they would have you do that. But, you know, they had it for us as well. Yeah.
Maybe wait till the end.
Yeah, but then it turns out to be that 2 is the distance always for the x, or the real value. But we, you know, you guys, whatever. Are you guys good? That was a long problems and stuff. Yeah, do the problems that you can, like the projectile motion. Definitely try to do the theorem one, because it's essentially using Pascal's triangle. And then if come back for that problem, or you know, find r, find rho, cosine, sine. Do as much as you can, but